Hello again. Now let's start with our last part of this very workshop. Let's now consider some infrastructure options for our freshly created AI applications. So when building our AI application, I think the first thing that comes to my mind is we need to decide on a hosting option for our language model. Typically, we can either use a cloud-based or a self-hosted model. Now, cloud-based models are typically provided by larger companies like OpenAI, which we've seen before, Claude, Anthropic, Azure AI, or the Google Cloud AI. And these services are very popular because honestly, they're super easy to use because we just have to sign up, connect our app to the service API, and we're good to go. And there's no further technical setup needed. They're also designed to scale up easily, so they can handle anything from, let's say, a small project to anything like a massive workload. Plus, these providers also regularly roll out new features and updates and improvements, so we're always getting the latest version of this technology. However, there are also some things to keep in mind with cloud-based models. Since these models really depend on the cloud infrastructure, we would always need a stable internet connection, and we're also tied to a third-party service, which means that we have limited control over the model itself and how it operates. There are also data privacy or security considerations to think about, especially if we were dealing with, let's say, any sensitive information like passwords or user data that typically would need to be safeguarded. And on the other hand, with self-hosted models using tools like Ollama, or there's another called llama.cpp, we can get a lot more control because we run everything on our own instance, which gives us the full control over both the model and the data and the data flow, because we can always customize the model to suit our specific requirements and needs. And this setup can also offer enhanced privacy and security because, well, my data isn't going anywhere outside of my environment. But this type of hosting a language model isn't without its challenges either, because we do need some technical expertise to set them up and maintain these models properly. Also, we need to have the right hardware, as mentioned earlier, to support them. And of course, the responsibility for keeping the system updated and running also falls on us. So how do we decide which one is best for us? Well, let's say if we were working with highly sensitive data, we might lean towards a self-hosting model options since we'll have a lot more control over the security and the data. If that is not possible, we should think about anonymizing or hashing the data before using a cloud-based model. Also, if we were planning to handle very large or maybe unpredictable workloads, maybe cloud solutions can offer more flexibility for our app. And in the end, it's always coming down to how much penny is spent. So it's always worth comparing the cost of cloud subscriptions with what it would cost to maintain my own local infrastructure model. Also, like I've mentioned earlier, models can be customized to fit the used infrastructure. So it's also important to consider the factors which would also influence the inference speed when deploying large language model application. What I mean by inference speeds, inference speed is about how quickly our model can process and generate responses to user input. So basically, it's about how quick is the model. And some factors which can affect this inference speed include the hardware acceleration, because when we're using specialized hardware like graphic cards, GPUs, or TPUs, we can significantly speed up this inference by using something called parallelized computations, which GPUs and TPUs offer, which is especially useful for large-scale applications or complex ones because the CPUs work much slower as they're working sequentially. Then there's the model size, because smaller models generally provide faster inference times, and while they may sacrifice some accuracy, they're often more practical for real-time or, let's say, resource-constrained environments. And I've already talked a little bit about quantization, which involves sort of reducing the precision or the length of the model's parameter weights, such as converting them from, let's say, a 32-bit integer to only an 8-bit integer. And so essentially, quantization can greatly improve our inference speed and reduce the memory usage without a, let's say, significant loss in performance like we would have with the actual parameter size. And last but not least, there is caching, which is about storing common responses or intermediate results to save computation time for frequently repeated queries, which further improves efficiency. So, but maybe you now might wonder, what if I wanted to use multiple models for different tasks in my application? Well, this is something where something called language model proxying comes in. And it basically allows us to intelligently route our requests to any different model I want to have based on factors or tasks I would like to differentiate between. So you've already just seen it. This routing technique can be done with the tool called LiteLLM. So let's take a brief look. What is LiteLLM? LiteLLM can be seen as an open source framework which is designed to simplify working with multiple language models. So it provides a standardized API which allows us to call over 100 different LLMs with ease. So we get a unified interface which translates all of my inputs to any rigid provider-specific endpoints, making sure that we have a consistent response formatting across different providers, which means that I can easily switch between models like OpenAI, Anthropic, Google Gemini, Azure OpenAI, whatever, Hugging Face, and more without having to rewrite my entire code base. So the benefits are clear because it simplifies a multi-model management, it reduces complexity, and it requires minimal code changes when switching between providers. So in this short demo, I would like to quickly show you how you can use LiteLLM to manage multiple LLMs in a single application. Here's what's happening in this code. So first of all, I load my Open API key from my environment file so I can use ChatGPT 3.5 Turbo. And then I set up two models. One for research with a slightly higher temperature to make it a little bit more creative, and another for summarization with a lower temperature to keep it focused. I then also initialize a DuckDuckGo search tool to perform the actual web searches. Now, the workflow is then managed using a state graph, which simply defines the process in two steps. So first of all, the research agent takes the user's query, it performs a web search, and it then stores the results. And then a summarization agent should take those results and generate a summary using my GPT model, and it updates the state. Now, exactly, these are my steps or my nodes, so to say, of the graph, and I need to define them for LangGraph. And I do this right here. Sorry. Now, the graph also connects these steps with edges right here. Starting with the research, moving to summarization, and then ending. And finally, I can compile the graph into an app and define a function to run the whole application. And in this case, when I provide a query, the app should search the web, summarize the result, and give me a concise output. So it's just a simple automated way to research and summarize any topic. So let's run this for a second. And I've already inserted my research topic, which is about who is Indiana Jones. The first one searched for my topic about Indiana Jones. The second agent then compiled or created the summary about Indiana Jones, which is exactly what I wanted. And that would be it for my last demo, how we can build the graph. And now, in my case, I try to create a graphical representation of my agentic workflow. You can see it's very simple, as we only have the two agent nodes, research and summarize. And there is only one way to go from research to summarize, but it still describes the process of my agent workflow. Now, keep in mind that we can design our workflows virtually any way we want, or we can also have multiple agents working together to achieve a common goal, which can be useful for more complex tasks, which would require collaboration between different agents or tools. And in this example, we can see multiple agents sort of working for a supervisor agent, which then coordinates their actions and manages the overall workflow. And depending on the task, would call the appropriate agent to perform the required action. In fact, we have several patterns for multi-agent interactions. We already know that we have the single agent or the supervisor agent approach, like we just seen before, but there are also more, like the network, which where agents communicate and collaborate with each other to achieve a common goal without a central coordinator. Or we could also go the other way around and use the hierarchical pattern, where agents are organized in a sort of hierarchical tree structure with higher level agents coordinating more lower level agents. Or don't forget, we can simply design our own pattern depending on the task and the requirement we want to achieve. And yeah, as we can do even more different tasks with AI agents, there are basically so much more use cases for them. We could use them in customer support, handling inquiries through chatbots or voice assistants, filing their own complaints or whatever. We could use it in content creation, writing blogs, emails, or marketing content, in data analysis, for example, by summarizing trends or generating reports or graphs. So much more. And who knows, maybe we can sometime create a huge agent workflow that can handle field or expertise independent tasks. So yeah. But I think we've heard enough for today, and I really hope you enjoyed the workshop so far. But before we end our session, I would like to summarize the key takeaways from what we've talked about today. So I know it really has been a lot today. So we started off by exploring general AI in DevOps and understanding how AI can help us with automating repetitive tasks, improve issue detection, or bridging skills in teams. Then we went into the sort of core fundamentals of AI, generative AI, and large language models, where we learned about how these models work and their role in sort of changing natural language processing and the way we interact with AI. We then moved on to running our own language models, discovering tools like the OpenAI platform and, of course, Ollama to run our models in the cloud or locally. And, of course, understanding the infrastructure they would require. Next, we then looked at prompt engineering, where we learned about techniques like zero-shot, few-shot, or chain-of-thought prompting to optimize or change or direct large language model outputs the way we want them to. And we've explored retrieval augmented generation, which combines the strength of natural language generation of language models with an external data source to improve accuracy, reduce hallucinations, or simply enhance the relevance of the output. Then we continued by building some different LangChain applications by using its tools to create AI workflows. We integrate vector stores and we manage prompts effectively. We also talked about the importance of ensuring quality and securing in our app, discussing things like testing, monitoring, or even implementing guardrails or security measures to maintain a reliable and ethical AI. Also, we looked at or we considered some operational considerations where we covered cost management, API limits, caching strategies, but also performance monitoring to ensure that our app is scalable and efficient. And last but not least, we just explored agents, which are autonomous systems which are capable of performing complex multi-step workflows and how they can, sort of revolutionize the task automation or decision making. So before I finish, I just wanted to add some closing thinking or some closing words, because what we've covered is, I mean, it was much, but it's just the tip of the iceberg. We know that AI has been a hot topic for years now, and I still think it's evolving so fast and it has a lot of potential to change the way we work and live. And we haven't really talked about AI agent tools like Devin, for example, which is not only completing code snippets, but it's also writing entire program and even debugging itself or setting up dependencies all by itself. And I've also briefly mentioned Claude's computer use, I think, or if not, computer use can basically use your graphical interface of your computer to solve tasks you give it. And so there's definitely going on so much more in the AI world. And I just think it's so important to keep up with all of these latest trends and technologies. And I'm clearly not here to say that AI is here to replace us. We can definitely see that it needs some guidance, and therefore I just think it's important to have some understanding of AI and its implications. And I hope this course has at least let you take a peek behind the curtains. And with that being said, I think this would be it for my workshop presentation for AI in DevOps application. And I really hope that we've made you hungry for some more AI topics. And on the behalf of my whole team, I would like to thank you all for your attention.